Good evening, everyone. I welcome to the crash course of PCAL Academy for Chemistry. So today let us start fourth chapter, carbon and its compounds. The first thing in this chapter is what is carbon. Carbon is a non-metal and it has the atomic number 6. It is very important element because it is present everywhere in the living system. You just go on making the list and you will see that carbon is present everywhere. Like the basic of life, carbohydrates, fats, proteins, vitamins, hormones, nucleic acids, they all contain carbon in them. Other than this, the things that we eat or consume also contain carbon, like the food grains, pulses, fruits, vegetables, fat, sugar, tea, coffee, they all have carbon in them. Not only that, the clothes that we wear, like cotton, wool, nylon, terylene, they have carbon. The fuels that we use, like wood, coal, kerosene, LPG, CNG, petrol, diesel, they have carbon in them. The cleanliness materials like soaps and detergents, they all have carbon in them. So it's surprising how is it that all these substances have carbon in them. The list is not over yet. You can see the medicines. Antipyretics are the medicines which reduce fever. Analgesics that have pain reliever in them. Antibiotics are the ones which fight infection. Sulfur drugs are also antibacterials in nature. They all contain carbon in them. Paper, plastic, rubber, leather, everything has carbon into it. So the surprising thing is, how is it possible, or what is the reason behind it? So this all is a part of organic chemistry. It is a branch of chemistry which is dedicated entirely to the carbon compounds. So we call it organic chemistry. Now we are going to discuss how is it that so many things have carbon in them. So you can see the answer here on screen, that it is because of the atomic structure of carbon. Atomic structure of carbon. We know the atomic number of carbon is 6. Because the atomic number of carbon is 6, it has the configuration 2, 4. 2 electrons in the first shell and 4 electrons in the second shell. You can see the diagram where the two shells are shown. These are 1 and 2 electrons in the first shell, and in the outer shell 1, 2, 3 and 4. Now to complete the octet, 4 electrons are less. So what happens is, carbon does the mutual sharing of electrons with other atoms to complete the octet. It does the mutual sharing because it cannot gain 4 electrons, it cannot lose 4 electrons. So we'll see what is the reason behind it. If suppose it gains 4 electrons, then what happens is the total number of electrons in carbon becomes 10, because 6 original electrons plus 4 the electrons which are gained. Now in the nucleus there are 6 protons only, 6 positive charge, 6 positive charge, but the electrons are 10. So it becomes difficult for 6 protons to hold 10 electrons. It becomes difficult. So gaining of carbon is not possible. Okay. Now losing electrons. To lose 4 electrons, it needs a very large amount of energy. which is practically not possible. So losing of electrons is also not possible. So in short, carbon cannot gain 4 electrons, cannot lose 4 electrons. So the only method left is sharing electrons. Carbon shares 4 electrons with the other substances to become stable. Here you can have a 2-mark question asking why carbon can't lose or gain 4 electrons and it cannot become C4 minus or C4 plus. This is not possible. So you can have this question. The answer is there on screen. Right? Now, as I told you, the only way is sharing. So carbon can share electrons with a variety of elements, thereby creating a variety of compounds. The first common compound, the simplest one, is shown here on screen, CH4, that is methane. CH4 is the formula for this compound, methane. You can see here one carbon atom attached to 4 other hydrogen atoms. So this is a covalent bond between carbon and hydrogen. Now what happens is, you can see here the electron shared between carbon and hydrogen. Hydrogen has valency 1 and carbon has valency 4. So here 4 electrons are shared, which are denoted by these lines. You can see here. They are denoted by these lines. So these are 4 covalent bonds. It makes the compound CH4, methane. Okay. So in this way, you can create several other compounds by mutual sharing of carbon with other elements. So as we have already discussed in the previous chapter, that when the electrons are shared between the atoms, it makes a covalent bond. So the simplest molecule that we get by covalent bond is the hydrogen molecule. Hydrogen has atomic number 1. So it is shown as this dot. Now this is the atom of hydrogen. It has 1 electron, which it is not stable. It must have duplet complete. So it shares 1 electron with the other hydrogen atom. You can see here, this is a pair of electron. One belongs to this, the other one belongs to this. Now they have shared the pair of electrons between them, thereby creating a covalent bond. This is the covalent bond between them. Now how to write it? This is how we write. This is hydrogen, a single line and another hydrogen. This represents the covalent bond here. This represents the covalent bond. Right? Helium is another element which we know is a noble gas. It is stable because it has 2 electrons in its shell. So hydrogen tries to become like helium. So in doing that, it shares the 2 electrons. So hydrogen attains the noble gas configuration as helium. The nearest noble gas to hydrogen is helium. So these are the diagrams which denote the covalent bond formation between them. Right? Now, because one pair of electron is shared between the 2 hydrogen atoms, we call it a single bond. And hydrogen is monovalent because it has valency 1. The valency of hydrogen is 1 over here, right? But if you see the molecule of hydrogen, it has 2 atoms. One molecule of hydrogen has 2 atoms into it. So we call this molecule as diatomic. Di stands for 2. So the molecule of hydrogen is diatomic. So these terms you need to remember. One is related to valency because the valency is 1, it is monovalent. Then it has got a single covalent bond between them because one pair of electron is shared, and it is diatomic in nature because it has two atoms into it. Now, how to draw this? This is how we draw. When they ask you to draw the structure, the electron dot structure, you simply need to show the shared pair of electrons between two hydrogen atoms, right? Then we have chlorine. As we know, the atomic number of chlorine is 17. It has the configuration of 287. So we need to show just the 7 electrons. So this is how we show it. This is 1, 2, 3, 4, 5, 6, and 7. And for the other chlorine, 1, 2, 3, 4, 5, 6, and 7th. So the 7th electron is shared between the two. So it makes have the octet complete. So this is how one chlorine atom makes a covalent bond with another chlorine atom. And we write it as Cl2. So this is also monovalent. This is the chlorine atom as we discussed just now, sharing of electron, one pair of electrons. So it has got a single covalent bond. Now the next one is oxygen. The atomic number of oxygen is 8. So it has the configuration of 2 and 6. Now here you can see the molecule, the atom of oxygen having 6 electrons, 1, 2, 3, 4, 5, and 6. The outermost shell has 6 electrons. So it shares 2 pairs of electrons between them. 2 pairs of electrons. Because 2 pairs of electrons are shared between them, it has got a double covalent bond. This is a double covalent bond, right? And we write oxygen as O2. So this is also diatomic. This is also diatomic. So in this way, we get the molecules by the sharing of electrons. So everywhere you can see the covalent bond formation. Next is nitrogen. Nitrogen has the atomic number 7. So 2, 5 is the configuration. Nitrogen atom has 5 electrons. 1, 2, 3, 4, 5. Let me show you the diagram. You can see here nitrogen atom sharing 3 pairs of electrons. 1, 2, and 3. Because 3 pairs of electrons are shared between them, it creates a triple covalent bond. Triple covalent bond. And we write nitrogen as N2. So this is diatomic and trivalent because the valency is 3 over here. Okay. So we have seen all the 3 here: single covalent bond, double covalent bond, and triple covalent bond. Okay, one example of each you have seen. These are the diagrams that show. In case you want to make the models, these are called the ball and stick models. The line between them is called the bond, and the spheres are the atoms. Right now, if nitrogen and hydrogen combine together, having valency 3 and 1 each, we get the compound ammonia, NH3. This is ammonia gas. Ammonia gas. The formula is NH3. Because you can see here, the 3 pairs of electrons are shared between hydrogen and oxygen. So if you want to make the structure, you can make it like this. This is one hydrogen, this is another one, and this is the third one, and two electrons are free here. So this is the structure of ammonia. Then we have oxygen and hydrogen. We make water out of it. You can see one pair of electrons shared here. So this is oxygen having one covalent bond with each hydrogen. The formula is H2O. All right. So between the compounds also bond formation takes place. Now, the question is what would be the electron dot structure of carbon dioxide, which has the formula CO2. Now we know the valency of carbon is 4 and oxygen is 2. So here it will share the electrons like this. Now you need to show the electron dot structure, so you can simply do it using the dot and cross. These are the electrons here. So now you can see it has total 6 electrons. 3, 4, 5 and 6. So this oxygen will be happy with these 8 electrons. 1, 2, 3, 4, 5, 6 and 7, 8. This oxygen will also be happy with the 8 electrons like this. You can count here. And even carbon is happy because it has these 8 electrons into it. 1, 2, 3, 4, 5, 6, 7, 8. So this is how we draw the structure. This is the simple structure and this is the electron dot structure. Okay. So it is easy to draw these kind of diagrams. Now the next one is what would be the electron dot structure of a molecule of sulfur, which is made up of 8 atoms of sulfur. Now sulfur has valency 2 and it has 8 electrons. So they are arranged in form of a ring. In fact, I would call it a crown in zigzag manner. Let me show the diagram to you. This is the one, like this. You can see here 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms, like this in a crown shape, like this. Okay. Now, the difference between the two, you can see here in the first one, sodium is losing electron to chlorine to get NaCl. And here the electrons are shared between the atoms to make H2O. So if you remember, we have already discussed this in the last chapter, that the compounds which are formed by transfer of electrons are called ionic compounds, and the ones which are formed by sharing of electrons are called covalent compounds. So this is the basic difference, the first main point of difference between ionic and covalent compounds. There is a strong force of attraction between the ionic compounds. So they have high melting and boiling point. This we have discussed, as I told you before. The, the mode of formation is transfer of electron for ionic compound, and for covalent compound it is sharing of electron. This is the first difference. The ionic compounds have ions and covalent compounds have molecules as the smallest unit. Then the physical states. Ionic compounds are generally solids in nature, but covalent compounds can be solid, liquid, or gas. Then melting and boiling point are quite high for ionic compounds. The reason is the strong force of attraction between the ions. And for covalent compounds, the melting and boiling point are low because the force of attraction between the molecules is low. So it needs less amount of energy to make them apart. Solubility: ionic compounds are soluble in water because water is a polar solvent, and covalent compounds are insoluble in water but they dissolve in the organic solvents. The examples are there in front of you: alcohol, benzene, petrol, ether, chloroform. These are the organic solvents. Electrical conductivity: ionic compounds do not conduct electricity in solid form, but yes, they are good conductor in molten or aqueous form. Covalent compounds do not conduct electricity at all because they don't have ions over here, right? So these are the main differences between ionic and covalent compounds. Finally, ionic reactions undergo complete reactions, means they will completely change into products. The reactants will completely change into products, but covalent compounds do not reach completion. Okay. Now, carbon is so versatile. What is the reason of carbon being so versatile? As I told you before, that carbon has valency 4, so it can bind with another carbon atom, which can bind with one more carbon atom, can bind with one more carbon atom. In this way, it can have a long chain of carbon atoms. This property is unique to carbon. No other element can do this way. Carbon has the property of binding with another carbon atom. This is called catenation. This is called catenation. Because of catenation, carbon has large number of molecules or a variety of molecules. So first reason is catenation. You can see this long chain of carbon over here. Because of catenation, we can have either a straight chain, a branched chain, or a cyclic molecule. This is the cyclic molecule. So this is all because of catenation, one carbon atom binding to another carbon atom. This happens because carbon-carbon atom is very strong. The bond between carbon and carbon is small in size. It is small in size, and that is why it is strong. You can create a large number of you can create a long chain having large number of carbon atoms. It won't break that easily. So we have so many carbon compounds. Now this property of catenation is seen in silicon also, but it is not as good as carbon because you can have maximum 5 to 7 silicon atoms joined one after the other, but after that the chain will break. The reason is that the bond between silicon is not very strong. It is not a strong bond. So it cannot hold a large number of atoms into it. Because carbon has valency 4, it is called a tetravalent and it can bind with several other elements. It can bind with hydrogen, it can bind with oxygen, it can bind with nitrogen, with sulfur, thereby creating a variety of compounds. So because of these two reasons, carbon is very versatile. The two reasons are catenation and tetravalency, right? So you can read the answer. They often ask this for 2 marks. Now let us see the compounds which are made out of catenation. The first compound that you see here is made out of one carbon atom. Now because the valency, is 4, we have 4 hydrogen atoms here. So it is CH4, and this is called methane. The compound is methane. It is, the common name is biogas. CH4 is the compound, and this is the electron dot structure. If you remember few slides back, I have told you how to draw the electron dot structure. You have 4 valency for carbon and hydrogen having valency 1. Now, when hydrogen can be satisfied with the 2 electrons, so here you can see hydrogen molecule, hydrogen atom, and carbon is also satisfied with 8 electrons. So you can just take them together. This makes the electron dot structure. Okay. So methane is, as I told you, a biogas. The common name is CNG also. It is monovalent in nature, but hydrogen is monovalent, carbon is tetravalent. This is one of the hydrocarbon. Hydrocarbons are the compounds which are made of only hydrogen and carbon into it. Methane can be represented in 3 ways. So this is called the structural formula. The first one is the structural formula. The second one is the molecular formula for methane. And the third one is electron dot structure for methane. So you can be asked question in any of the way. If you are asked to draw the structural formula, this is what you draw. If they ask you the electron dot structure, this is what you have to draw. And molecular formula, everyone knows. Now 2 carbon atoms here. One of the valency is already satisfied with this. There are 3 more remaining here for each carbon. So we can attach 6 hydrogen over here with 2 carbon atoms. So that makes the formula C2H6, and this is the electron dot structure. This is called ethane. Ethane is another hydrocarbon, because here also you can see it is made only out of hydrogen and carbon. Now we will see few more hydrocarbons. We already have done methane and ethane. Now with the compound which has 3 carbon into it is called propane, and this is the formula. Then we have butane for 4 carbon atoms. For 5 carbon atoms, it is pentane, hexane for 6, heptane for 7, octane for 8, nonane for 9, and decane for 10. So this is a series of hydrocarbons. This is a series of hydrocarbons starting from methane to decane. So here, if you see, they all have single bond between them. All the structures have single bond between them. Such hydrocarbons which have single bond between them are called alkanes. So this is the series of alkanes. They all have single bond between them. So this is the definition of alkanes. All hydrocarbons having single bond between them are called alkanes. Okay. Now we'll see the molecular formula. The first one is CH4, then C2H6, C3H8, C4H10, C5H12, C6H14, C7H16, C8H18, C9H20, C10H22. You can see a pattern over here. If we discuss about methane, CH4, if we take it as 1, this is 4, let us take it this as N. So it is CnH2n plus 2. Means if N is 1, if carbon is 1, hydrogen will be 1 into 2 plus 2, that is 4. If you take N as 2, hydrogen will be 2 into 2 plus 2, that is 6. If you take N as 3, hydrogen will be 3 into 2 plus 2. It will be 8. So everywhere this formula, this general formula is 2, CnH2n plus 2. So that becomes the general formula for alkanes. This becomes the general formula for alkanes. Okay. This is the general formula for alkane CnH2n plus 2. Now, if you see the molecular mass for methane, it will be 16 because carbon is 12, hydrogen is 1. Then we have 30, 44, 58, 72, 86, 100, 114, 128 and 142. Again, you can see a pattern over here. The molecular mass is increasing by 14. You can see here. Everywhere it is increasing by 14, right? The reason is at every step there is an increase of CH2, 1 carbon and 2 hydrogen. So 12 plus 2. This is the increase everywhere. So the adjacent member of this series is having an extra carbon and 2 extra hydrogen. Now, because the molecular mass is increasing over here, the physical properties change. The physical properties change. The gradation in the physical properties is seen like melting point, boiling point, density, solubility. So it is called gradation in physical properties. All right. Now, this is the list of some common alkanes with their formula, their melting point and their boiling point. You need not remember this, you need not memorize this. You just have to understand. I mean, it's just for your reference to see how the gradation in physical properties is seen. So you can see the melting point starts with this number minus 182.5, but then it ends at a positive number 65.8. Such a great increase. Same is with melting point. And then the physical state. So this is the gradation in the physical properties. Right? Then you can see the ethane molecule here. Now, in this structure, in the second structure, you can see this bond has got broken. There was a bond over here. The bond has broken. And because the bond has broken, the electrons are free now. The electrons are free. So what happens is, because the electrons are free, this molecule becomes unstable. But it has to get stability. So what does it do? These two carbon atoms form a bond here. And these two hydrogen atoms form a bond here. This makes hydrogen gas. This makes hydrogen gas. And this molecule becomes something like this. Carbon, double bond, carbon, hydrogen, 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 and hydrogen. So now you can check the valency for carbon. It has 4. 1, 2, 3, 4. 1, 2, 3, and 4. So the valency is 4 for both of them. But now it is not ethane. It has converted to a double bond compound that is called ethene. It is called ethene. So we can change ethane to ethene. We can change propane to propene like this. We can change butane to butene, pentane to pentene, and so on. They all have at least one double bond between them. You can see this is a double bond. This is a double bond. a double bond, double bond, double bond this way. So this series, which has a double bond between them, a double covalent bond, I would say. Double covalent bond is called alkene series. It is called alkene series. Now you can see here, if this is 2, this is 4. If this is 3, carbon is 3, hydrogen is 6. If carbon is 4, hydrogen is 8. So everywhere it is doubling. It is doubling. So if C is N, hydrogen is 2N. You can confirm. If carbon is 5, hydrogen is 10. Carbon is 6, hydrogen is 12. So this becomes the general formula for alkenes. CnH2n for alkenes. So alkenes are the compounds which have a double bond between them. Okay. These are unsaturated because they don't have two hydrogen are less in number with them. So they are called unsaturated ones. Now, similarly, we can convert a double bond compound into a triple bond compound, and this will be called ethyne. The suffix over here is "-ine", Y-N-E. The moment you have a triple bond, the suffix becomes "-ine". So here you can see the triple bond. The general formula for alkynes is CnH2n minus 2. Okay. So because of catenation, you can have long chain, branch chain, or a ring. This is possible because of that. Moreover, you can have saturated or unsaturated also. You can see here, this is the straight chain, and then we have a branch over here. So we have discussed about the carbon compounds today, which have a single bond, double bond, and triple bond, which are straight chain, branch, and cyclic compounds. So if any questions